Today we are going to learn three things. First of all, looking at this power plant, we're going to learn how a power plant works, basically how we burn coal or oil or natural gas and generate electricity. Second thing we're going to learn is about the efficiency of each of these devices. And the third thing that we're going to learn is when three devices are combined together, the boiler, the turbine, and the generator, how the efficiency drops, cumulative efficiency. So this is the part that is called generator, what generates the electricity. Electricity generation is a simple operation. If you look at the physics, it's very simple. We need a magnet. We have a magnet here. The red one is a magnet. And we need a copper wire, or a conductor, basically. A conductor is inside here, which is wound around this armature. And this copper wire, when it turns in the magnetic field, you get electricity. Let's see. If you turn this, actually the bulb is not turning on. The reason is we don't have enough energy here, or the speed is not enough. Let's look at this again. Now, it goes. Which means that if we are able to somehow turn this armature in the magnetic field, you can generate electricity. There are two ways in which you can generate electricity. You can go to the power plant and keep on turning this when we don't need any, coal or oil or natural gas. Or we could use some other way to turn this armature. That's what I'm choosing here. I'm using steam to turn this generator. So to generate steam, we need a fuel. So we have a fuel that we are going to burn and generate the steam. And this boiler is filled with water. Normally this is supposed to be full with water. And that's what we're going to do. We're going to fill this with water. And once it is full, we can start the fire. This is closed. Now, I'm going to light this fuel. All right, we're lighting the fuel here. This is camp cook fuel, methane amine, smokeless fuel. As you can see, it's kind of a little difficult to get it going, the fire. But once it burns, this is the place where you would be using coal or oil or natural gas. So I'm sticking it into this boiler. So now the fire is inside, and it is boiling this water. This water boils and turns into steam. I'm going to close this valve to make sure that the pressure inside is built up to a level that it can turn this turbine. And when this boiler really burns coal or oil or natural gas, the combustion gases, which consist of carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxides, all of them go through this stack. This is where most of the pollution goes out when you burn the fossil fuels. And the steam goes through this pipe and then turns this turbine like an engine. And when this turbine turns, you turn the generator. See, I'm going to turn this one now to your side so that you can see the fire inside the boiler here. So you can see the fire inside the boiler. So it is lighting up. The fire is turning slowly this water into steam. There is a glass here through which you can see the level, actually. In a power plant, the operators monitor the water level. If the water level goes too low, it's dangerous. You're running the boiler dry. If the water level is too high, again, there is not enough room for the steam to be there. So once the steam is built up, again, the pressure is built, we can see how that steam turns the turbine. There are two things that we want to learn from here. One side is this pollution that in the next chapter that we'll be talking about, how much of these gases are going into the atmosphere and creating the problems for us like global warming, acid rain, and ozone formation at the ground level and so on. The second pollution that you normally see from a power plant is not all the energy that we are putting into the steam really is used to turn the turbine. You can always see from here when it is turning, more than half of energy comes out in the form of steam that is going out, like in a car you see the tailpipe gases coming out. See, the light is going really good. The bulb is turning on and it's turning at high speed, and this is where the energy is. Actually, the steam is coming out. It's really hot here. So you can see the water actually condensing on my hand. This is where half the energy is going out, what we're putting in. So the efficiency of this power plant is only 35%. 90% of what we put in is coming into the turbine here, and this turbine is putting out only 40% of this 90, which is about 36 units, and this generator is turning that into about 35 units of electricity. So overall, when we start our business with 100, we're coming out with 35 units of electricity. So the overall efficiency is only 35%.